friends, how are you? Today in this video I am going to explain about the electric field. The topic I have mentioned here, electric field and potential, which is extension of the same topic, electric charges and field. In fact, it is very difficult to visualize the force between two charges because there is no physical contact. So it is difficult to visualize the force between charges. It is difficult to visualize the force between two charges. That's why in 19th century Michael Faraday introduced the concept of electric field. Subsequently it was developed by Maxwell. First, it was proposed by Faraday. Afterwards, it was developed by Maxwell. The concept of electric field. In earlier classes, you have studied about the gravitation. In that gravitation, a particle in its surrounding creates one gravitational field. That gravitational field exerts a force if a particle placed in that field. That means the particle creates the gravitational field. Gravitational field apply the force on the particle placed in it. So I can say that it is a two-step process. Similarly, here also I can say that a charged body or a charge creates a electric field surrounding it. That electric field exerts force on a charged particle when placed in it. So I can say that the electric force is a two-step process. Like the gravitational force, the electric force is a two-step process. The electric force is a two-step process. What is the two-step process I said? First one, it creates electric field. Next, it apply force on the charged particle which placed in that electric field. So I can say that it is also a two-step process. Now, this electric field has two characteristics. The electric field has two characteristics. What is that? One is the direction. Second one is the magnitude. So, what is the direction of the electric field? If the charge is positive, its direction is outwards. if the charge is negative, its direction is inwards. Why it is like that? Because the direction of the field is the force experienced by a positive charge. The direction of the field is the force experienced by a positive charge which is placed in it. I can say that the direction of field is the direction of force experienced by a small positive charge where it is placed in it. Suppose this is the positive charge. This is called the source charge. Now, this is the surrounding. Here is the positive charge is there. This charge generally we say test charge. Then this is positive. This is also positive. So in this case, the direction will be outwards. The direction, because this positive charge will experience one repulsive force. If this source charge is negative charge, then the direction of the field will be towards it. It will be towards it, because it will attract the positive charge. Here it will repel, that's why it is outwards. Here it will attract, that's why the direction of the field is towards, or you can say inwards. So this field takes finite time to propagate. The electric field takes finite time to propagate. Takes finite time to propagate. For example, we displace the position of the charge particle. Charge particle was here. Now I displace to here. So definitely it will take some time. For example, I want to find the electric field at this point. So in this case, it will take some time, because I displace it from one point to another point. So field at a particular point will take some time, that is T equal to R by C, where is the R is the distance, R is the distance and C is the speed or velocity of the light. So the magnetic field takes some time, but finite time to move. We can calculate the time by using the formula R upon C. So now I can define the electric field. So what is that electric field? So I can say that the region of space, region of space. The region of space surrounding a, or you can say surround a charge or configuration of charges in which a positive charge particle experiences a force when it is placed in it. So listen carefully. The electric field has its own existence. The electric field has its own existence. What own existence? Suppose this is a charge particle. It will create one electric field. Other charge particles are there or not to experience does not matter. But definite, it will create one electric field. If there is charge particle to experience, not there to experience does not matter. But it will create its own electric field. Okay. So that's why I said that the electric field has its own direction. This electric field has two characters. What are the two characters? Characteristics of electric field. One is the direction, second one is the magnitude. These are the two characteristics of the electric field. Then what is the direction of the electric field? The direction of the electric field. The direction of the electric field is the direction of force experienced by a small positive charge when it is placed in it. So the direction of the electric field is the direction of force experienced by a small positive charge. We say that is the test charge when it is placed in it. See that how it is. If the source charge is positive, this is the charge, source charge we say, which creates an electric field. Then the direction of the electric field will be outwards because this is a positive charge. So there will be a repulsion. So if the source charge is positive, the direction of the electric field outwards, and if the source charge is negative, the direction of the electric field will be towards. So this is outwards, this is inwards. That means the electric field has directions, and the direction depends upon the direction of the force experienced by the positive test charge. This charge is very small, no doubt at all. So now I can say that electric field is a vector quantity. Now you see that now I define the electric field, and I said that it has direction as well as magnitude. Next point is about the electric field intensity. Electric field intensity. What is electric field intensity? This is the quantitative measure of strength of the field. I can say that the quantitative measure of strength of the field at a point. Then how I can define? I said that a charged particle, a system of charge creates one electric field. The field at every point has a direction as well as a magnitude. That means it has a strength. The strength of the magnetic field at a point, that is called the electric field intensity. It is also abbreviated as electric field. What is electric field strength, electric field intensity, or electric field? Same thing. So, how can I define this electric field intensity? So, this is the, I can say that the force experienced by a single unit of positive test charge. The force experienced by a single unit of a positive charge when it is placed in an electric field. When it is placed in an electric field which is created by a charge or system of charges. Listen carefully. The force experienced by a single unit of a positive test charge, I can mention is here Q naught. When it is placed in an electric field which is created by a charge or system of charges charges, that is called electric field intensity. I can write that E is equal to A by Q naught. Here E stands for electric field intensity. E stands for force experienced by a positive test charge, which is Q naught I have mentioned here. So electric field is the ratio between force to the positive test charge. I have written E equal to A by Q naught. This is about the electric field intensity, often referred as electric field. So we can say electric field, and I said that it has direction as well as magnitude. So what is the SI unit of electric field? Its unit is Newton per Coulomb. In SI system it is Newton per Coulomb, and in ESU, electrostatic unit of CGS system, it is dyes per start Coulomb. So in SI system it is Newton per Coulomb, whereas in CG system or electrostatic unit we say it is dyes per start Coulomb. So this is about the electric field intensity, or you can say electric field strength, or often it is abbreviated as electric field. Let us see one numerical problem to make it more clear. What is that? Calculate the force experienced by an alpha particle when it is placed in a uniform electric field of intensity 5 into 10 to the power minus 4 Newton per Coulomb. The question is that calculate the force experienced by an alpha particle when it is placed in an uniform electric field of intensity or strength 5 into 10 to the power minus 4 Newton per Coulomb. So we know that E equal to F by Q, or I can write that this F equal to U into Q. This force is equal to E into Q. Force is the product of electric field and charge or field intensity. That is what is field, that is field intensity, that is the strength of the electric field. So your strength is given how much? It is given 5 into 10 to the power minus 4 into charge of alpha particle. Alpha particle is a positively charged helium nucleus. That means which contains 2 protons. So I can say that 1.6 into 10 to the power minus 19 coulomb. Okay. So here this is Newton per coulomb. This is coulomb. So I can say that. So 5 into 2 10. 10 into 1.6 16. Okay. So 16 into 10 to the power minus 23, or you can write 1.6 into 10 to the power minus 24. Oh, sorry, I made mistakes. So this is 5 into 10, 1.6. 16 into 10 to the power minus 23, or I can write 1.6 into 10 to the power minus 22 Newton. Okay, I have divided 10 and multiplied also 10. So this is about the electric field. And one thing I want to say that since electric field has a direction, so the net electric field can be calculated vectorially, since electric field is a vector. It's the resultant field at a point calculated vectorially in the sense, for example, Q1 is a charge. Due to that one, at this point electric field is U1, and Q2 is another charge, and due to that at this point the electric field is E2. So the net field E is equal to E1 plus E2. Since it is a vector, so we can calculate it vectorially. So this is about the electric field and electric field intensity. So for this video, this is the end. Until the next video, bye.